Welcome to week 11 in geometry. So we are in week 11, which we're also in the week of October 25th. I do have a warm-up problem that I want you to complete in your math notebook, and this warm-up problem is pulling all the way back from algebra last year and even pre-algebra the year before, where I've got two linear equations and I want you to determine if the lines, and we know they're lines because it's a linear equation, if the lines are parallel. And then how do you know? So go ahead and take some time to try this out in your math notebook, and then when you're ready to check your work with mine, go ahead and click play. So click pause so you can try this in your math notebook on your own, and then when you're ready to check your work with mine, go ahead and click play. Alrighty, so linear equations. Let's do a quick review of linear equations. And a familiar form of linear equations, which we call slope-intercept form. And that is written with y equals mx plus b, where the m term represents the slope and the b term represents our y-intercept. So to answer this question, we're going to focus on the slope of our equations because we want to determine if these two lines are parallel. And if you recall from algebra classes, your algebra class last year, when you have parallel lines, what do we know about the slope of parallel lines? What do we know about the slope of parallel lines? So parallel lines will have the same slope. So parallel lines are going to have the same slope. Same slope. So that means that looking at these two equations, we need to figure out what the slope of these two equations are and then compare those slopes. So in order to compare the slopes, we need to get the equations into slope-intercept form, or get y all alone on one side of the equation and then have this mx plus b on the other side of the equation. And if we look at the first equation, 3x plus 8 equals y, that's already in slope-intercept form. We've got y all alone, and then we've got the 3x and the 8 all alone on the other side. So what is the slope? So remember, the slope is going to be the number that's multiplied by your x term. The number being multiplied by your x term. So what's being multiplied by the x term? 3 is. So the slope of our first equation is going to be 3. I'm going to actually move all this stuff over a little bit so I can write. All right. So the slope of our first equation is going to be equal to 3. What about our second equation, 2y minus 6x equals 8? Well, unfortunately, that equation is not in slope-intercept form, so we need to do some rearranging. We need to get y all alone. So to get y all alone, I'm going to work on first adding 6x to both sides of my equation, and then I get 2y equals 6x plus 8. And then my last step is to get y all alone, I need to divide by 2. And whatever I do to one side of my equation, I'm going to do to the other side. So remember, each term is being divided by 2. We've got 6x divided by 2, which is 3x, and we've got 8 divided by 2, which is 4. So what is the slope of this equation? Remember, it's the number being multiplied by your x term, so it's 3. So the slope is 3. So now we have the slope of each equation. The slope of our top equation is 3. And the slope of our second equation is 3. So what does that tell us about these two slopes are the same? So does that mean that the lines are parallel? It does, because we reviewed in the beginning that when you've got the same slope, the lines are parallel. So because these two slopes are the same, then yes, these lines are parallel. So in order to be parallel, the slopes of two lines have to be the same. And you're going to be using that this week. So some quick reminders, make sure you're checking your grades tab frequently. Look for missing assignments, look for assignments maybe you started but didn't finish. Remember, you can tell if you've got a missing assignment in the grades tab because it will not have that little green puzzle piece next to it, and most likely a 0. And then something that I'm still having students not doing, and I've said this several times, you need to message me when you submit missing or late or redo assignments. So please make sure you message me. It's not going to take you long. Otherwise, I'm not going to know to grade your late work. So you need to message me when you're submitting late work or redos in order to get those graded. All right, so what are we doing this week? We're going to start by taking the Unit 2 test, so wrapping up Unit 2, all about triangles, and then we're going to move on to Unit 3, which is all about quadrilaterals. But before we really get to quadrilaterals, those four-sided shapes, we're going to do some reviewing on lines and slopes. And we're doing that because quadrilaterals are made up of 4 lines. So it's going to help us when we go to look at properties of quadrilaterals with having some reviews of lines and slopes. And then we're also this week going to review systems of equations. So let's jump in and do that right now. So we already did the warm-up question where we reviewed parallel lines will have the same slope, and in order to determine that, we need to figure out what the slopes of 2 lines are, and sometimes that requires us doing some rearranging like we did with the second equation to get into slope-intercept form so that we could quickly identify what the slope of the line was. All right, so let's look at another question that has to do with linear equations. So let's read the question. It says, which line is parallel, so parallel is a key word there, is parallel to the line with the equation y equals negative 2x plus 5. So what do we know about parallel lines? We know that parallel lines, we will have the same slope. And here we're given an equation of a line that's already in slope-intercept form. Remember, slope-intercept form is y equals mx plus b, where m represents your slope. So what is the slope of this line that we are given? Y equals negative 2x plus 5. What is the slope of that line? The slope of that line is the number being multiplied by the x, which is negative 2. So that means that the line that's going to be parallel to that must also have a slope of negative 2. So let's look at our options. It says which line is parallel? Well, our choice F, we're not given a slope, are we? But we're given 2 points that line AB intersects. We're told that line AB goes through point A at 2, 3 and point B at 2, 1. Do we have enough information to figure out the slope? We do. So remember, we can use the slope formula, which when we're given 2 points, the slope formula is that we find our change in our y values over the change in our x values. So let's go ahead and do that. So this is our first coordinate, the 2, 3. So we're finding the slope between 2, 3 and 0.11. So this would be our first x and our first y. This would be our second x coordinate and our second y coordinate. So we're going to subtract our y coordinates. So 1 minus 3 all over our second x coordinate minus our first x coordinate. And what do we get? Looks like we get 1 minus 3 is negative 2, and then 1 minus 2 is negative 1. So that is a negative divided by a negative is actually a positive. So the slope would be 2 over 1. So that's not the same slope as what we're looking for in up above. We need to find a negative 2 slope. So that would not work. That would not work. F is not an option. What about G? We've got an equation already in slope-intercept form. What is the slope of that line? It's negative 1/2. So that is not the same as negative 2. So that would not be parallel. What about H? So unfortunately, h is not in slope-intercept form. So we would need to quickly put equation h in slope-intercept form. So right now we've got 4x plus 2y equals 10. We need to get y all alone. So we're going to first subtract our 4x from both sides. So we can get it in slope-intercept form. We need to get y all alone on one side of the equation. What do we have? 10 minus 4x. And then we're going to get y all alone, dividing each side by 2. And then remember when I put that, all those terms over 2. So I'm taking 10 divided by 2, which is 5, and negative 4 divided by 2, which is negative 2x. So what's our slope here? Slope would be negative 2. So that matches. So we do know that this line would be parallel. We do know this line would be parallel. So let's go ahead and highlight that. That one would work. This one would work. What about our last option, option J? Let's really quickly see if that one would work. So I'm going to do that down here, J. We've got the equation x plus 1/2 y equals 1. We're not into slope-intercept form, so we need to subtract x from both sides, and we get 1/2 y equals negative x plus 1. And our last step, we need to get y all alone. Right now it's 1/2 y, so to undo that, we're going to multiply each side by the reciprocal, which is 2. So whatever we do to one side of the equation, we have to do to the other. So I need to multiply each term in the equation by 2. So now I get y equals negative 2x plus 2. What is the slope of this line? It is negative 2. So we know that this line would also have to be parallel. So we've got 2 of them in that case. All right, so I'm going to move on to the next slide. So if you need more time here, go ahead and click pause. All righty, in Unit 3, Session 2, you're going to move on to solving systems of linear equations. So I wanted to review what a system of equations are and how we solve them. So a system of equations is a collection of 2 or more equations with the same set of unknowns. And then when we solve, what we're trying to do is find the values of each unknown that will make both or all equations true. So let's look at an example. So here we've got 2 equations, y plus x equals 6, or x plus y equals 6, negative 3x plus y equals 2. So what we're trying to do is find a value of x and a value of y that when we plug that same value of x and y into both equations, it makes both equations true. So the equation of this set, or the solution of this linear system of linear equations is 1, 5, because it's going to make both equations true. So let's see that work. So this solution is written as a coordinate 1, 5, which means that x equals 1 and y equals 5. So when I plug those values into each equation, it will make the equation true. So x plus y would turn out to be 1 plus 5 equals 6. That's true. That works. Then when I plug in x is 1 and y is 5 into the bottom equation, what do I get? I get negative 3 plus 5, and that does in fact equal 2, so that's correct too. So a solution of a system of linear equations is a solution that when we plug it into both or all equations will make each equation statement true. There's a couple of ways that we can solve for systems of equations, and we did this back in algebra. One way is by substitution, and that's when we take one equation and we plug it into the other equation. And it works really well when you've got like y equals 2x. We've solved for y in our first equation. So we've got y equals 2x, and then our second equation is y equals 4x plus 12. So because the first equation is already solved for y, it allows us, whenever we see a y in our second equation, we're going to plug in 2x, because we can only solve for one variable at a time. So when we say y equals 2x, I'm going to plug in 2x wherever I see y in my second equation. And now look, I only have one variable I'm solving for. I only have x. And now I can actually solve for x. So remember, you can only solve for one variable at a time in an equation. So let's solve for x. We're going to get all of our x terms on one side of the equation by subtracting 4x from both sides. And now I've got negative 2x equals 12 divided side by negative 2. And what do I get? X equals negative 6. X equals negative 6. Well, I'm not quite done. Remember, I need to solve for both my variables, x and y. So now what I'm going to do is I'm going to go back and look at my two equations, and I'm going to plug in my value of x equal negative 3 into one of those so I can solve for y. And I'm just going to choose that top equation because it's pretty straightforward. Y equals 2x. So remember, I solve for x. I know that x equals negative 6, and then I can solve for y. So y would have to equal negative 12 because 2 times negative 6 is negative 12. So my answer as a coordinate would be negative 6, negative 12. Or that x equals negative 6 and that y equals negative 12. And I can check by my work by plugging it into the bottom equation and seeing if that works as well. So let's go ahead and do that. So y should equal negative 12. X equals negative 6 plus 12. So I've got negative 24 plus 12, which equals negative 12. So we solved correctly. So here's our two solutions down there. And that's how you use substitution. You have one equation that's solved for one of your variables, and then you can plug it into the other equation. Just like we did, we plugged y equals 2x. 2x we plugged in for y, and we solved for x. Remember, you always have to solve for both variables, so don't stop once you've solved for one variable and think you're done. All right, I'm going to move on to the next slide. So if you need more time here, taking down good notes, go ahead and click pause. All right, another way we can solve systems of equations is by elimination. And that's when we add our two equations together. And when we add our two equations together, we're going to eliminate a variable. So looking here, I've got positive y and negative y. So this sets us up really nicely to solve for elimination. So again, remember when you use elimination, you're adding your equations together. So because we have a positive version of a y and a negative version of a y, it allows us to use elimination really nicely. So let's see what happens when we add our two equations together. So 2x plus 3x gives us 5x's. Our y's cancel out, and 9 plus 16 is 25. And now we've got a nice equation with just one variable, so we can go ahead and solve for x by dividing each side by 5. And we get x equals 5. 25 divided by 5 is 5. Now remember, I'm not done. I need to still solve for my y variable. So I go back up to my original equations. I choose either one. I'm just going to choose that first equation, 2x plus y equals 9. And now I'm going to substitute in my x equals 5 and solve for y. 2 times 5 is 10. 10 plus y equals 9. Subtract each side by 10, and I get y equals negative 1. So my solution as a coordinate, I could write it as 5, 1, and that's the same thing as saying x equals 5 and y equals negative 1. And that's our solution there. And we solve by eliminating. And then the nice thing is we can always check our work by plugging it into the bottom equation as well, that 3x minus y equals 16, and it would work there as well. So that's how we solve by elimination, is we look to see if we can eliminate a variable by adding the two equations together. I'm going to go into the next slide, so if you need more time, please go ahead and click pause. The last way to solve systems of equation is by graphing, and I'm running out of time here. I want to keep this under 20 minutes. So to solve by graphing, all you would do is get your two equations in the slope-intercept form, which remember is y equals mx plus b. And then you would graph your two equations, and this is not the graph, I'm just doing two random lines, and see where they intersect, and that would be your solution. So again, I'm running out of time here, so I'm not going to graph those two. You'll see that in your lessons this week. Alrighty, so that brings us to the key phrase assignment. Let me get up those 2 questions for you. There are 2 questions you need to answer this week. The first one is, what do you need to do if you submit a late, missing, or redo work assignment? Then the second equation is, how can you tell if 2 lines are parallel by looking at... So again, there are 2 key phrase questions you have to answer. You need to answer both these questions to get full credit this week. Answer both questions, and directions to complete the key phrase assignment are below if you need them. Have a wonderful rest of your week, and as always, if you need any help, reach out and let me know. I'm here to help.